So this is the first question that I have bought for you guys. This question again is going to help you out in revising a lot of stuff. Let me read out the question first of all. You guys also read the question properly with me. This is a fantastic question. It's a time consuming process, but definitely you are going to learn a lot of things from here and also revise thoroughly. Okay, let me just read the problem for you guys. A water storage tank is 15 meter high. So the water storage tank is 15 meter high. Nice, excellent. Has a drainage opening on one of the vertical sides. So it's a cubical tank kind of a thing is there, which is actually 15 meter high, and it is having an opening on one of the vertical side. At the bottom, the opening is having a shape of a trapezoidal. That is very, very important to note down, that it is having a shape of a trapezoidal with a width of 2 meter at the bottom and 4 meter at the top. So that trapezoidal shape that he's talking about now, the top width is 4 meter, the bottom width is 2 meter. Okay. And the height of the trapezoidal gate is 1 meter. Okay, nice. A gate of the same dimension. So there is this trapezoidal opening is there at the bottom of the tank, and at the bottom of the tank, to cover up that opening, you are having a same gate in the shape of a trapezoidal you have installed over that. So that fellow is asking you, what is the minimum horizontal force required to be applied at the bottom of the gate to keep the gate in a closed position? The water level in the tank is 11.5 meter. That is very important. See, the total height of the tank is 15 meter. The water level in the tank is 11.5 meter. So all the calculations you guys know already are going to be done on the basis of the free surface level, and that is 11.5 meter. Above the water, this is the crunch point in this problem, and you are going to thoroughly enjoy this, that above the water level in the tank, there is actually air having a pressure of minus 14.715 kilopascal, gauge pressure of course, oh my god. So actually you can say that this is a problem of pressurized chamber. I don't know whether you guys know the concept of pressurized chambers or not. Okay dear, so it is basically a problem of pressurized chamber. Now let us solve this problem. I will tell you, don't worry, what is the meaning of pressurized chamber here. Okay, so this is the rough diagram that I have already made on the board. The total height of the tank is 15 meter. It is containing water, you guys can see, up to a level of 11.5 meter. And there is this trapezoidal opening is there. Okay dear. And this trapezoidal opening, the top width is 4 meter, the bottom width is 2 meter, the height of this is 1 meter. Excellent, students of India. So now you see, over this trapezoidal gate, you know, from the top, a gate is actually hinged, which is in the shape exactly that of this trapezium. Okay, so it's a trapezoidal gate, and water is here. So water is going to apply the force over that gate, hydrostatic force over the gate. For water, the trapezoidal gate is going to be a plane surface, and it is going to apply so that the gate opens. But that fellow is asking you, what should be the minimum force you should apply at the bottom of the trapezoidal gate so that the gate doesn't open up. So here basically we need to apply your balancing of moments equation. But wait, the most important thing is that above this liquid level, there is air. There is air above this liquid level, and this air is not having a pressure equal to atmospheric pressure. Rather, the pressure of this air is given as minus 14.715 kilopascal. So the pressure of this air is minus 14.715 kilopascal. Please have patience. These are very beautiful problems. 715 kilopascals. So therefore, there is a pressurized air over the liquid surface. So whenever the liquid is pressurized with something, then you need to find out an imaginary liquid surface. Now, how to find out that imaginary? So the calculations are not going to be done on the basis of this free surface. Come on, guys. Whenever there is a pressurized chamber is there, the calculations is not going to be done on the basis of this free surface. First of all, you should release out this pressure and create an imaginary liquid surface. Now, how to create that imaginary liquid surface? Very simple. See, this much of pressure is there. Convert this much of pressure into water head. Convert this much of pressure into water head. How do we do that? See, pressure is how much? So, pressure you need to convert in terms of water head. So, how to convert any type of pressure in any fluid head? Very simple. Just divide that particular pressure with respect to rho g of that particular fluid. So, pressure is already known to you guys, and divide it with rho g of water, because you want to convert this pressure in terms of water head. So, how you are going to do that? So, pressure is, important thing is that the pressure is minus, that the pressure is negative. So, this is minus 14.715 into 10 to the power 3 to convert into Pascal, divide by rho g of water. So, rho g of water is going to be 10 to the power 3 into 9.81. When you are going to solve this, this is going to come out to be 1.5 meter, but with negative sign of water column. So, whatever pressure is above this liquid surface, you know that pressure is equivalent to minus 1.5 meter of the water column. So, the imaginary liquid surface, you know, this is your original liquid surface is there, above which there is pressurized air. But you need not do the calculations on the basis of this. You need to do your calculations on the basis of imaginary liquid surface. So, imaginary liquid surface will be present somewhere here. So, from the original liquid surface, you will decrease the liquid surface by a height of 1.5 meter, water head. Okay, and do your calculations on the basis of that. This is the technique. Already in the classrooms we have discussed questions like this. So, I hope you are enjoying this revision course. So, therefore, original height was the 11.5. Now, you are going to decrease this height by 1.5 meter. Come on, guys, concentrate on board. So, now you are going to decrease this height by 1.5 meter. Okay, dear. So, original was 11.5. You have decreased its height by 1.5 meter. So, this means this yellow color liquid surface, this which you have seen, this can be written as imaginary water surface. Imaginary water surface. Okay, dear. So, imaginary water surface will be at a height of how much? Total original was 11.5. 1.5 meter decrement. So, how much is it? It is going to be 10 meter is going to be the total height. Total height of this imaginary liquid surface from the bottom. Okay. Now, see, this height of the trapezium is 1 meter. So, this much of height is going to be how much? 9 meter. Now, we should solve our problem. See, what is going to be the concept behind solving this problem? Very simple. Trapezoidal gate is there. Find the hydrostatic force. Okay. Find the point of application of that hydrostatic force. Then find the moment of that force from the top. Okay, dear. Because the gate is hinged at the top. So, first of all, find the force. Force is going to be W A x bar. Everybody knows it's a plane surface. So, W is going to be water. So, this is 9810 multiplied by area of the surface. It's a trapezoidal gate. So, for trapezoidal gate, what is the area? Half into sum of parallel sides. Sum of parallel side is 4. 4 is one of the parallel side plus 2. 4 plus 2. Half into sum of parallel side into height. Height is how much, bacha, of the trapezium is 1. So, this is area multiplied by x bar. What is x bar? X bar is the vertical distance of CG of the surface from the free surface, and it's a trapezium. Now concentrate on board. For this trapezium, the CG of this trapezium is going to lie somewhere here. Come on guys. The CG of the trapezium is going to lie somewhere here. Now how many students know from our classroom that how to find the distance of this CG from this 4 meter side? Very simple. The distance of this CG from the 4 meter side is going to be twice of the opposite side. Let me make you revise. See, if you talk about trapezium, in the classroom we have seen beautifully. If this side is A and this side is B, okay dear, and this is going to be the CG of the trapezium. I'm making you revise because this is a revision through questions course. So therefore, you know, if you want to find the distance of this CG from this parallel side, which is B, your distance is going to be 2A plus B divided by A plus B into H by 3, where H is the height of the trapezium. Excellent students of India. So you see, this is going to be, you are trying to find out the distance of CG from the 4 meter side. So the formula is going to be twice of the opposite side. Okay. So 2 cross 2, because opposite side is 2, 2A plus B. B is how much? 4, something like that, divided by A plus B, that is 2 plus 4, into H by 3 is 1 by 3, into 1 by 3. My dear students, when you are going to calculate this, I am already having the answer, so I am sharing with you guys. Yes, this is going to come out to be something. Okay, very good. So this is 1 by 3. Excellent students of India. But is this your X bar? No, this is not X bar. X bar is going, see, now all the calculations you are going to do on the basis of imaginary water surface. So where is the imaginary water surface? Here it is. This is your imaginary water surface. And this is your CG distance. Now see, from the imaginary water surface up to this point, see, the total height is 10 meter, but up to this point, the height is going to be 9 meter. So 9 meter plus this much of distance is going to be X bar, So let me write that. So this is going to be, X bar is going to be 9 plus. What is the distance of CG from the 4 meter side? Distance of CG from the 4 meter side is going to be 2 into 2, very good, plus 4 divided by 2 plus 4 into height is kitna? 1 by 3, into 1 by 3. Excellent students of India. My dear students, when you are going to calculate this force from here, you are going to get the answer as 277.95 kilonewton. This is going to come out to be 277.95 kilonewton. You can cross check the calculations. This is going to be the force. But just by finding the force, you are not going to get the answer, my dear students. You need to find the point of application. Now, how to find the point of application? See, it is a vertical gate. So if it is a vertical gate, the point of application of the force will lie at a distance of h from the free surface. What is the formula for h? We have studied in classroom. X bar plus Ig divided by ax bar into sine square theta. My dear students, it's a vertical gate to the free surface. So theta is going to be 90. So this is going to be 1. So h value will be equal to x bar. So what is the distance x bar from the free surface? What is the distance of x bar from the free surface? This much is the distance. Okay dear. So when you are going to calculate this distance, this will come out to be 9.444. So this is going to come out to be 9.444. Okay dear. Plus Ig. What is the moment of inertia about the centroidal axis for a trapezium? For a trapezium, the value of Ig, I am writing the formula here. The value of Ig for a trapezium comes out to be a square plus b square plus 4ab divided by 36a plus b into h cube. That's your formula for your moment of inertia about the centroidal axis. So this is going to be 2 ka square plus 4 ka square plus 4 cross 2 cross 4 divided by, come on guys, concentrate on board, divided by 36 into a plus b, that is 4 plus 2. Excellent, students of India. Multiplied by h cube. How much is the height of the trapezium? Is 1 meter. Is 1 meter. Okay. So this is 1 ka cube. 1 ka cube. Very good. This is your Ig divided by area. Area of the trapezium is going to be half into sum of parallel side is 2 plus 4 into height is 1. This is the area multiplied by x bar, and x bar is 9.444. So when you are going to do all these calculations, the value of h will come out to be, 9.453 meter, 9.453 meter. Now just observe what your teacher is trying to say. Just observe what your teacher is trying to say. See, you know, my dear students, if this is center of gravity, and center of gravity distance from the imaginary water surface is 9.444, which we have already written on the board. You know, the center of pressure of the force is going to lie somewhere here. And this center of pressure of the force is going to lie at a distance of h from the free surface. H from the free surface. And from this point, this is the trapezium, and from this pink color point which I am showing, the water force is going to act like this and is going to make the trapezoidal gate move like this. Are you getting the feel what I am trying to say, bacha? This is a fantastic problem. So therefore, force multiplied by distance from the hinge. So distance from the hinge is going to be h minus 9. Come on guys. What is the distance of the application of force from the hinge? Hinge point is the topmost point of the trapezoid. So therefore this height is h minus 9. Minus 9 is this much of distance. Okay dear, that is going to be the moment of the force. So therefore moment of the force. Very good. And to balance this force which is coming from here, you need to find out the minimum force required. For minimum force required, the moment should be maximum. So the external force so this is the trapezium, hydrostatic force is acting from there, and you will be applying the force somewhere here at the bottom, so that the minimum force is required. Okay dear. So therefore, if you apply external force to balance out the hydrostatic force here, then it is going to act exactly at the bottom at a distance of 1 from the hinge. So now balance out all the stuff. See here. So therefore this is the external force which you will apply, multiplied by 1 is the balancing moment. And what is the imbalancing moment? Imbalancing moment is this hydrostatic force 277.95. 277.95 multiplied by distance of this force from the hinge. Distance of this force from the hinge is going to be h minus 9. Distance of this force from the hinge is going to be h minus 9. And from here, when you are going to calculate this external force, this will come out to be approximately 125.90 kilonewton. That's your answer. So a mind-boggling question. With the help of this problem, you have revised the concept of your pressurized chambers also, okay? And also the trapezoidal gate is also got taken care of, okay? So I am moving aside the screen. You guys can pause the video here and write down. Take everything in your register. So this was the question slide. This was the question slide, my dear students. This was the solution slide. Let me just minimize it so that you can take in a proper manner. Yes. So this was our solution slide, first slide of solution. You can pause the video here and take the solution. This is your third slide, the answer slide, and that's your answer. 125.90 kilonewton. Excellent. Beautiful problem to start off this lecture.